Okay, we're back for round two. Just a couple more things that I wanted to touch on. So we left off figuring out the opposite side, which is this side, and it's the side that we care about because this part of the force of gravity is actually pulling the block down this ramp. So this is force of gravity in the x direction. Remember that our coordinate is tilted, so x is going parallel to the slope and y is perpendicular. So this is what we care about, mostly because the force of gravity in the y direction completely balances out with the force or the normal force. So force of gravity, we do sine of 20 is equal to the opposite over the hypotenuse. The hypotenuse is 50. The force of gravity vector right there is how we get the hypotenuse to be 50. So when we solve that out, we get the opposite side to be 17.1. I'll just call it 17. And that's going to be 17 newtons. So we're going to use Newton's second law in the x direction here and do F net equals m times a, and this is acceleration of the block in the x direction. So 17 newtons is equal to, well, our block's mass is still 5, and I can figure out the acceleration by doing 17 over 5. And that will tell me just how much this block accelerates down the ramp. And remember, this is without friction. So what if we introduced friction? Well, the same setup as how we would start this problem. We have to identify our forces. So I have my force of gravity, and this block's mass is still 5 kilograms. So my force of gravity is still going to be 50 newtons down. I still have my normal force, Fn. And this time I have force of gravity. Now force of friction. And force of friction opposes motion. So this block wants to slide down the ramp. The force of friction is going to try and oppose that. So, I think there are a couple problems, let me see here, where you're trying to solve for the force of friction. Find the friction force, yes. So, the first problem says that the block is completely still. It's at rest. So when we break up the force of gravity vector, we're going to do this again. And remember, this is going to be 20. The hypotenuse is going to be 50. We solve for that. And we're going to break this up into a y vector and an x vector. And remember, the coordinate system actually shifts. So that's x, this is y, and we just turned it a little bit. So if this block is completely still, it means all the forces balance out. So the normal force balances out with the y component of gravity. And similarly, the x component of gravity balances out with the friction force. So though we don't know the friction force, you can find it because you can find the force of gravity in the x component. And because everything's the same numbers, the x component is still going to be, force of gravity in the x is still going to be, oh, that was sloppy. It's still going to be 17 newtons. So that's this side right here. And of course you could do cosine to solve for this length right here. And hopefully you're still seeing this triangle. So this 17 also has to be the force of friction. These two balance out if this block is completely still. Now if the block is accelerating, then you would do your 17 newtons minus the force of friction equals ma. And that's because we're using Newton's second law every single time. Net force equals m times a. We know that the y components still balance out because there's no acceleration of this block in the y direction. It's all in the x. So if this thing starts sliding, we have acceleration in the x direction. So we find Fg, x component, minus force of friction equals ma. So 17 minus force of friction, I'll write this out. 17 minus force of friction equals m, which is 5. I'll throw that in. And say in the second page problem it tells you the thing accelerates with 2 meters per second. You could throw that in and you can actually solve for the force of friction. You got 17 minus force of friction equals 10 newtons. So isolate force of friction, you could solve for that. And I know this is a lot. I know that trig is overwhelming and frankly just takes some practice. So do your best on it. Thanks for reminding me to get some videos to you. I hope this was helpful. And I do look forward to seeing you and everyone else in Honors Physics tomorrow. So enjoy the night, study hard, and I will see you tomorrow.